this is Miss Israel coming at you from Einstein High School. We're going to be looking at Unit 2, Topic 2, Question 37. Look at the pattern of small squares below. The number of small squares, n of t, is a function of the figure number t. So they show us a pattern here, and we're talking about the number of small squares. So I'm just going to go ahead and label this. We have 1 square, 2 squares, 4 squares, and 8 squares. And we want to draw the pattern for figure number 5. So let's figure out what is the pattern. Hopefully we see to get from 1 to 2 to 4 times 8, we're going to be multiplying times 2 each time. 1 times 2 is 2, times 4 times 2, 8. So we're dealing with a geometric sequence here. Okay, so to continue to get to figure 5, I'm going to multiply times 2, and I need 16 squares. Let me see if I can draw that. So try my best here. So 1, 2, 3, 4, 5, 6, 7, 8. Let's make sure we have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. And sure enough, I do. And my picture is not very pretty, but I do have 16 squares, so that's going to be figure number 5. All right. Complete the table for figures number 1 through 7 for the number of small squares. So we know we've actually pretty much already made our own little table there. Oops, I lost a page. So let's complete the pattern. We knew that at figure 1 we had 1 square. At figure 2 we had 2. And we continued to multiply times 2. I'm going to do that quickly. And 64. Okay. All right, part C, make a graph for the number of squares. Okay, so let's use the table. I'm actually going to, let's see if I can move this over here so I can look at both things together. Okay, so I am going to start at figure 1. There was 1 square. At figure 2, we had 2 squares. At figure 3, we had 4 squares. I'm just estimating ever so slightly. It doesn't have to be perfect. Figure 5, we had 16. At figure 6, we had 32. And at figure 7, we jumped all the way up to 64. So I hope you can see the shape of this is a curved graph, kind of like so, and that's because it is an exponential or geometric pattern that we're looking at. So it should not be in a straight line. And I'm not going to connect the dots because this is a discrete function. We're jumping from one value to the next with nothing in between. Okay. Okay, part D says write the recursive formula for the sequence of the number of squares. All right, so we know that n of 1 was equal to 1. We know that we had a rate of 2, or a common ratio of 2. So we're going to go 2 times the previous term. And that's going to be our recursive. All right, the explicit formula, again, we're starting with f of 1. So that was 1 plus, 1 times, geometric, I should know better, 2 to the power of t minus 1. I have to do that minus 1 here because we started at 1 instead of 0. So to make up for that, I do n minus 1. It's like I'm jumping backwards by doing that to 0. Okay. Is the sequence of the number of squares arithmetic, geometric, or neither? Explain why. Well, we already answered that question, didn't we? We figured out that this pattern was geometric. The pattern shows a common ratio of 2. And there's a lot of ways you can explain that. You are multiplying times 2, however you want to word it, but do be specific. Use a number, use the words common ratio, or at least multiply to show that you know that the difference between a geometric and an arithmetic is whether or not we are dealing with multiplication or addition. Okay, that's going to do it for question 37.